All right, so we've been going over probability, and I've started talking about independent and dependent events. What we had were the difference between dependent and independent. So a dependent event is an event where you take part of something, you remove it, and then the second time it makes a difference. So in this case, we started with 3 marbles. If you draw, this is a green marble, this is a purple marble. The colors don't come up because I have a black and white printer. But if I draw this marble out of these 3 that are in the bag, all that are going to be left is going to be 1 green or 1 purple. Same thing if I draw that marble. All I'm left would be a green or a purple. If I drew the purple marble, all that would be left would be 2 green. So that has an impact on the number of possible outcomes that I have. So here I have 3 possible outcomes. Coming down here, each one of these only has 2 possible outcomes. So it's a matter of figuring out the probability. So to get a draw where you draw 2 green marbles in a row would be you have to draw a green marble on your first draw and a green marble on your second draw. That can happen here or it can happen here. So the other possibilities would be green purple, or purple green, purple green. In total, you have 6 possible outcomes: GG, GP, green purple, green green, green purple, purple green, or purple green. 6 possible final outcomes, but only 2 would be green green. 2 out of 6, or 1/3 of a chance. In the second activity, you're doing the same thing except you're replacing the marble you've drawn. So I draw a green marble on my first time, I put it back. The second time I can either draw the same one again, I can draw the other one, or I can draw a purple. The same process repeats, telling us that we end up having 9 possible outcomes. So if I wanted to draw 2 greens in a row in this independent type event, where the second draw is not impacted by the first draw, independent of it, I would have 1, 2, 3, 4 possibilities of getting consecutive green marbles out of 9 we count. Okay, next page. Read through this, we're not going to do it. You can work with yourself if you want to. It's not a great thing to do online. Now this discusses again, dependent or independent. And then it goes through and it explains what they are. So, independent events that does not affect the likelihood of another event. We've gone through that in the notes. Dependent is it does affect the likelihood. So like you're picking a kickball team. I can go through, I can pick Bruce. He's the awesome kicker. He's going to do great at fielding. He's wonderful. I pick Bruce. When Mr. Peppers is picking, he can't pick Bruce. His action is dependent on what I've done. But instead, he selects the powerhouse pitcher. I can't choose that person my next term. That would be dependent. Whereas if I wanted to pick a purple marble and I had a bag full of them, I can keep putting it back and putting it back until I get my purple one. I'm not taking them all out until I get my purple one, then I can stop. Independent or dependent. Okay, so this goes through, you can follow through this. Heads or tails, I can again, independent, heads or tails, that side doesn't disappear. The probability is the number of times 2 heads can occur over the total outcome. 1, 2, 1 time out of 4. And you can make these probability trees if you are confused. It's an easy way to branch out and to see what options you have. Okay. Same thing, there's 28 flowers in this vase. 7 purple, 9 yellow, 12 pink. 7 plus 9 is 16, 16 plus 12 is 28. What is my odds of pulling a purple flower in my first draw? Well, there's 7. 7 over 28, 1/4. Okay, now what if this is dependent? What if I want to pull a second one that's yellow? So there's 9 yellows, but I've already pulled 1, so I only have 27 left. So I have 9 over 27. What would then be my probability of getting an A and a B, a purple, then a yellow? Yellow after purple, you take the 1/4, take the 1/3, and we're going to multiply them. Get 1 over 12, or 8%. Okay. You can go through and answer 5. What if the probability of both flowers are purple? Let me work through that with you. Well, we know the first probability of A, where the first one is purple, is 7 over 28, or 1/4. Okay, I've pulled that purple flower. How many purple flowers do I have left? I only have 6 and 27. I can't reduce that, so what's my probability of A and B happening? Well, that would be 1/4 times 6 over 27. Well, that's 6 over 128. No, 108, I was right. Yeah, 108. 6 over 108. You can simplify that, of course. So the chance would be a 6 out of 108. Divide both by 3. Actually, 6 goes into that. 1 over 18 when I simplify. And percent, 1 divided by 18 times 100 equals 5.6%. So this is the work I assigned you. Vocab. Fill in the blanks. Well, flip 1. I can either get a head or a tail. Flip head or tail on that one. Head or tail. Head, tail, head, tail, head, tail. So what would be my possible outcomes? Head, head, head. Head, head, tail. Head, tail, head. Head, tail, tail. Tail, head, head. And continue on to the third one is tail, tail, head. That's what it should look like. So you should know the vocabulary. Events A and B are independent. Describe 2 ways to find the probability of A and B. Well, you find the probability of A and B through a tree or just through counting the odds. So, copy and complete the tree diagram. We've done that. Number 3, open-ended. Describe a real-life example of 2 independent events. Describe a real-life example of 2 dependent events. Well, an independent event would be flipping your coin. Not a real-life example always. Let's say going through your drawer and picking a sock until you find a matching one. None of your socks are folded together, they're not matched, they're not paired, but you have matching ones in there. So you go in, I pick a blue sock, I keep going in until I get 2 blue socks. Dependent would be the example of dodgeball. So, find the probability of rolling a 1 and then a 2, 4, 6. Well, the probability of a 1 is a 1 out of 6. Probability of 2, 4, 6 is 3 over 6, or 1/2. So the probability of A and B equals 1/6 times 1/2 equals 1/12. Well, what's the same thing? A 1 and an even number. Well, the only even number on the dice are 2, 4, and 6, so it's going to end up being exactly the same. All right, find the probability of rolling an odd, then an even. Well, how many odd numbers are there? 3. 1, 3, and 5. Or 1/2. What's your probability of even? Well, we just established that was 2, 4, and 6. 3 over 6, or 1/2. So what's the probability of getting an odd then an even? Well, the probability of odd and even equals 1/2 times 1/2. One-fourth. Find the probability of rolling a number less than 2 and then an even number. Well, how many numbers are less than 2? Only 1. So 1 out of 6. And then an even number? Well, there's 3 even numbers, 2, 4, and 6, so 3 over 6, or 1/2, 1/12. Less than 2 and even. Okay. You roll a number, so tell whether these dependents are independent or dependent, and explain. You roll a number cube twice. First roll, you roll a 4. Second roll, you roll an even number. So is that independent or dependent? Well, I'm rolling a die, 6-sided, I'm assuming. Am I removing that original number, that original roll, from the pool? No, that 4 is still a possibility. So this would be an independent event. Six, you flip a coin twice. All right, flipping coins. Well, do I remove the one head that I've already flipped if I flip a head? No. This will again be independent. You randomly draw a marble from a bag containing 2 red marbles and 5 green marbles. So how many marbles? 7. You put the marble back and then draw the second marble. So as long as you're returning your original option to the pool, it remains to be independent. Number 8. You randomly draw a marble from a bag containing 2 red marbles and 5 green. You keep the marble. Now in this case, if I draw a green marble, there's only 4 green marbles. That's changing my overall probability. Just like picking in dodgeball or kickball. That's dependent. You and your friend are drawing in a drawing for 2 door prizes. You can only win 1 prize. Well, if I already win the car and he only wins the blender, because that's all that was left, this would definitely be dependent. All right. A spinner has 3 equal sections numbered 1, 2, and 3. You spin it twice. Using the tree diagram, find the probability of the events. First of all, is this going to be dependent or independent? What do you think? Dependent or independent? Do I take a number off the spinner after I spin it? No, I don't. So this is all independent. They didn't ask, but it's good to know, so you can make sure you're doing it correctly. What's the possibility of spinning a 1 and then a 3? Should I work on some other paper for this? So this is number 10. Spin 1, then a 3. Okay, what's the chances? So remember, it's a 3-sided spinner. 1, 2, 3, they're all equal. What's my chance of spinning a 1? 1 out of 3. What's my chance of spinning a 3? 1 out of 3. Overall, the probability is you multiply them together. Multiplying fractions, top times top, 1. Bottom times bottom, 9. 11. Spinning an odd number, then 2. Okay, how many odd numbers are there? 1 and 3. 2/3. How many 2s are there? 1. Whoops. Out of 3 possibilities. 2/9. 12. I want you to go through, continue trying 12, 13, and 14 on that. I'm going to go and look over a couple of, so 12. I want you to work on those. I'm going to try number 15 now. All right. Number 15, you spin the spinner and flip a coin. Find the probability of the events. Does spinning the spinner have any impact on the coin? No, these are again independent. All right, how many spaces are on the spinner? 10. We're going to assume they're all equal. What's the chance of spinning a 4? Then heads. Well, 10 spots, total of 10 possibilities, but there's only 1 4. Okay, I have a coin. How many sides are on a coin? 2. 2 possible outcomes. How many opportunities do I have to get ahead? Just 1. Multiply them together, top times top, 1, bottom times bottom, 20. I have a 1/20th chance of spinning a 4 and then flipping heads. 1 out of 20, that's not great. So next one, 16, spinning an even and flipping tails. Okay, let's take a sec, look at our chart. Even numbers, 2, 4, 6, 8, 10. There are 5 even numbers. Even then tails. Well, we just established there's 10 possible outcomes. 5 of them are even. Times flipping a coin, 2 possible outcomes, 1 of them is tails. All right, top times top, 5. Bottom times bottom, 20. We can reduce that fraction. 5 goes into 5 once, 5 goes into 20 4 times. A 1 out of 4 chance of getting an even. It's not so bad. Number 17, a multiple of 3. That's something that has 3 as a factor. Well, 3 times 1 is that. 6 and 9. They're all multiples of 3. 3 can be divided evenly into it. So you want to look for something that can be divided evenly with 3. Spinning white and not flipping tails. So that would be 1, 3, 5, 7, or 9. And not flipping tails. Not flipping tails means you're left with heads. So take a look at 18 and 19. I guess 17, 18, and 19. 17 and 18. Okay, so I have more than halfway done. Awesome. I don't remember what I've assigned. All right, you randomly choose one of the lettered tiles without replacing the first tile. You choose a second tile. So I'm removing it, and I can't get that one again. So this is an example of dependent. So that means your second draw, there's going to be changes. Okay. Here are my tiles. DOOLNAR. When you're looking at this, they're two different colors. I'm going to assume that OOR, hang on, I'm going to pause it and I'm going to splice the videos back. Okay, welcome back. So I've established that the D, L, and A are green. These are green, 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 and these are yellow. Okay, what are my chances of drawing an R and then an N? Well, how many letters are there? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 7 letters. 1 D, 2 O's, 1 N, 1 L, 1 A, 1 R, 4 green, and 3 red. Sorry, yellow. What are my chances of drawing an R? Okay, how many R's are there? Oops. I'm looking at it. So I know I have a total of 7 tiles to draw from first. How many are R's? One of them. After that, how many tiles am I left with? I've taken the R out, I don't put it back. How many are N's? Just one of them. Okay, top times top, bottom times bottom. You have a 1/42 chance of getting that going. Okay. Number 20. A and L. So what's my probability of an A? How many A's are there? 1. How many, I'm starting fresh each question. How many L's are there? Or sorry, how many total? 7. How many L's are there? 1. How many tiles do I have left over? Well, I've taken 1 out, so I only have 6 left over. Again, a 1/42 chance. So that means 1 time out of 42 pulls, you are going to get it right. 21. D and O. Okay, how many tiles do I have? 7. How many are D's? 1. Multiply. How many are left after I've drawn my first tile? 6. And how many of them are O's? 2. Two over 42. You can reduce that. 1/21. Awesome, your chances are a lot higher this time, but still, it's going to take 21 tries. There's 22, and in yellow, 23, O, and not yellow. What's another way? What would be not yellow? Green. Squeeze 24 right down at the bottom here. What would be the possibility of drawing not an O and then an O? Okay, I want you to skip number 25. this was an old Florida worksheet. I don't want you to do 25. The name of a city in Florida. I don't know enough Florida city names, but I'm suspecting they're going for Orlando. Orlando. So what would that look like? I will do it for you just so you can see how probability can drastically change when you're given a large number. So, okay, number 25. This is omitted for you guys. I'm just going to do it for you. So I want to try to spell Orlando, and I have to draw the letters in that order. Okay, first draw. How many tiles do I have? 7. What are my chances of getting an O? 2. R. How many R's are there? 1. How many tiles do I have left? 6. 1L. How many tiles are left though? I've drawn 2. 5. N. Oh. A, sorry. Well, there's 1A, and there's only 4 tiles left. I've drawn another one. And this is the ideal situation. N. Well, there's 1N. 3 tiles. There's a 1D and 2 tiles and 1O and 1 tile. Multiplying the top times the bottom. 2 times 1 times 1 times 1 times 1 times 1 times 1 is 2. 2 out of 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 5,040. We can reduce that. One out of 2,520 times will you get that. Crazy. Okay, 7 times 6 times 5 times 4 times 3 times 2 times 1 is an arduous task to enter, especially if you're working in larger numbers. So there is a function called a factorial. And here it's x exclamation point. So whenever you see an exclamation point in math, it's telling you that you are doing x times x minus 1 times x minus 2 times x minus 3 until you get to 1. So what I would do is I would do 7 second function factorial, and it would give me that answer. Again, so that would be, if I do 7 factorial, just a trick to know would be 7 times minus 1 times minus 1 times minus, and so on. 4 times 3 times 2 times 1 equals 50/40. Just for when we get into bigger questions. All right. So now that we've gone through multiple possibilities, I'm hoping that you are able to do numbers 26, 27, and the other ones. So let's just look at 26, set it up. There's 4 earrings. 2 gold plus 2 silver. You randomly choose 2 earrings. What's the probability of both are silver? Well, draw 1. You have a 1 out of 4 chance. Sorry. You have a 2 out of 4 chance of getting silver first try. Times, well, how many are left? 3. Times that. 2 times 1 is 2 over 12, or 1/6. I said I wouldn't do it. I did. I'm sorry. So 27. You choose a 2-digit number at random. What is the probability your choice is correct? So this is trying to figure out your password. How many 2-digit numbers are there? We're assuming 10 through 99. Well, you can go through and count them. There's 89 options. What is the chance of getting it correct? Well, 1 out of 89. Suppose you remember both digits are even. How does this change it? Well, it changes it drastically. You can completely eliminate anything that starts with a 1, 3, 5, 7, or 9, and anything that ends in a 1, 3, 5, 7, or 9. So it drastically increases your probability. I want you to calculate that out. The next page, 28. Fish. You randomly choose 2 fish from the bowl. What is the probability the first fish is red and the second is gold? You have to look at the colors. I can't tell they're here. I think there's 1 red one and 4 gold. Taking a test. And I just want you to try these out, see the best you can figure it out. It's going to be a challenge, and that's what I want. I want you to kind of challenge it. You should be able to finish those first ones fairly easily. Numbers 1 through 27, I want you to finish them and work on the next ones. Thank you.